Hey guys, today we're going to be looking at solving two-step equations using algebraic thinking. So far we've used algebra tiles and other representations, and today we're going to connect that with a system or an algorithm of thinking that we can use. So I see our first equation as 2x minus 3 is equal to 1. If I was using my algebra tiles, I would need to create zero pairs, and I would want to create zero pairs with the units that are on the same side as the variable. So I see I have a -3. In order to create a zero pair, I need to have 3 positives. And because I do it on one side, in order to keep balance, I will put 3 positives on the other side as well. And now I simply need to simplify. That -3 and +3 makes that zero pair. So I'm only left with the 2 x's on the left-hand side. And my +1 combined with my +3 is a +4. So now I have 2 x's is equal to 4. And if you think of how we were solving it with our algebra tiles, it would look like this. We would have 2 x's equal to 4 positives. And that would be the time that we would then go and share all these units equally with the x's. Well, when we share things equally, that is just division. So instead of having 2x is equal to 4, I'm going to divide down. I'm going to scale down to find what 1x is. So I would divide both sides by 2. So 2x divided into 2 groups gives me just 1x, and 4 divided into 2 gives me 2. So I see that each x has a value of 2, which I can check. So they gave me this original equation of 2x minus 3 is equal to 1. And when I solved it, I got that x had to be 2. So I can take away this x right here and substitute in the 2 that I solved for. And it should make an equal statement. So I have 2 times 2, which is 4, minus 3, which is 1, and that is correct, so I know 2 is my solution. All right, let's look at one more. I have -9 is equal to -2y minus 1. So again, I want to take a look at the side of my equation that has my variable, and I want to make some zero pairs. So my unit is a -1. In order to create a zero pair with that, I will have to add 1. And if I do it on one side, I know I want to do it to the other because I need to keep the equation balanced. So now when I go to simplify my equation, I know that -9 plus 1 is -8. And that will have to equal that -2y has not changed. But -1 and +1 did cancel because they made a zero pair. So now we're left with -8 is equal to -2y. And if we think of how this would have been modeled with our tiles, we would have 8 negatives equal to 2 negative x's, or 2 negative y's, since that's the variable we're solving for. And this again is when we would equally share. I would say, hey, these 8 negatives, I can share 4 of them to each negative x. So I'm dividing into 2 different groups. So when I'm dividing into 2 groups, I get that -4 is equal to a -y. But remember what that looked like when our tiles, that -y being equivalent to 4 negatives, that was when we flipped our tiles because we did not want a negative variable. So I can find the opposite of -y, which is a +y. And the opposite of -4 is a +4. So I know that y is equal to +4. Another way that we could have done that is saying, okay, hey, I'm solving using inverse operations. So once I got here and I had that -8 was equal to -2y, y is being multiplied by a -2. So the inverse operation of that would be to divide both sides by a -2. So -2 divided by -2, that gave me just 1. So I'm left with only 1y. And -8 divided by a -2 was a +4. So again, we still arrived at the same answer. We just eliminated that step of having to find the opposite because we divided both sides by -2 all at one time. All right, thank you.